Welcome to our channel Learning Math. In this video, we're going to solve an extra problem in special quadrilaterals for grade 8. Here, consider a parallelogram ABCD such that AB equals AC. But before starting to draw, we should analyze the given. What does it mean AB equals AC? If you note from the name of the parallelogram ABCD, A and B are consecutive points, they are next to each other directly. So AB is the name of a side of this parallelogram, while AC, the points A and C are not consecutive to each other. So here AC is the name of a diagonal of this parallelogram. So we have this parallelogram having the side AB equal to the diagonal AC. Moreover, let M be the midpoint of BC, which is sure a side of this parallelogram, B and C are consecutive, and E be the symmetric of A with respect to M. So in part A, draw the figure. Let's start by it together. As you see here, we have drawn the side AB, which should be equal to the diagonal AC, and also since we have a parallelogram, the sides CD and AB are equal and parallel to each other. Now when we join them, we get the parallelogram ABCD. Now we have M is the midpoint of BC. As you see, we have BM equal to MC, and also we have E is the symmetric of A with respect to M. So we draw AM equal to ME. Now when we join them, if you note here, we get a rhombus ABEC, and if you note more, we have D, C, and E should be collinear to each other if our figure is correct. Now let's prove them together. In part B, show that AE is perpendicular to BC. How to prove that? First of all, we should analyze the given. The first information in the given, we have AB equals AC. Well, two equal sides. Shouldn't they give us an isosceles triangle? So we can say that triangle ABC is isosceles. Another given, we have M is the midpoint of the side BC. Well, M is the midpoint of BC. Can't we say that AM is median to BC? Well, in an isosceles triangle, the median issued from the principal vertex. A is here the principal vertex since AB equals AC. The two equal sides are issued from the point A. Well, in an isosceles triangle, the median issued from the principal vertex is at the same time height, altitude, which is at the same time named as height. It's also bisector to the vertex angle and perpendicular bisector to the side BC. So here we need it an altitude or height to BC. Can't we say in this case that AE is then perpendicular to BC, since we have A, M, and E are collinear by symmetry? Well, in part B, prove that A, B, EC is a rhombus. Well, if you know something, we have M is the midpoint of BC, and M is given, and M is the midpoint of AE by symmetry. Since we have AM is equal to ME, we have drawn E the symmetric of A with respect to M. Well, here we can say that the diagonals AE and BC bisect each other, but they are also perpendicular. We have just proved that. So we can conclude that AB, EC is a rhombus since its diagonals are perpendicular bisectors to each other. So they are perpendicular and bisect each other. Now deduce that C is the midpoint of DE. How to prove it? If you note something, we have just proved a rhombus. Can't we say that CE and AB are equal to each other as sides of the rhombus? But also we have AB is equal to CD as opposite sides of the parallelogram. Well, now we can conclude that DC is equal to CE. But can we say in this case that C is the midpoint of the segment DE? Sure not. Why? Note that we have AB equal to AC. Does it mean that A is the midpoint of BC? No, here M is the midpoint of BC. How can we get it as midpoint? We should not only prove that DC is equal to CE, but also we need to prove that D, C, and E are collinear on the same straight line. Now how to prove them? Note that we have CE and AB are parallel to each other as opposite sides of the rhombus. Also, we have CD and AB are parallel to each other as opposite sides of the parallelogram. So we can say that DC and CE are both parallel on the same straight line. Also, we have C is a common point between DC and CE. Well, therefore, in this case, we can say that D, C, and E are collinear. Why? They are parallel to the same straight line, so they should be parallel, which means they can never intersect. But since C is a common point, they intersected at the point C, so we can say that they are the same straight line, so D, C, and E are collinear. And also we have just proved that DC is equal to CE, therefore C is the midpoint of the segment DE. Now let I be the symmetric of A with respect to C. First of all, to construct the symmetry, we should produce it by the same length. So here we can say that AC should be equal to CI. Now let's prove that AEIC is a rectangle. Well, if you note something, we have given that AB is equal to AC, and also AB is equal to CD as opposite sides of the parallelogram. Then we can say that AC is equal to CD. Also, C is the midpoint of DE, so we have DC is equal to CE. Moreover, by symmetry, we have AC is equal to CI. Therefore, we can say that AC equals CI equals DC equals CE. So the diagonals of this quadrilateral are equal and bisect each other at the point C. Therefore, we can say that the quadrilateral AEID is a rectangle since its diagonals are equal and bisect each other. Thank you for watching. If you enjoyed this video, please like, share, and subscribe for the continuity of our channel to support you by more and more information with a great appreciation for your support.